Hello, everyone. Thank you for attending another of our NTCA technical webinars. This one is titled, Do You Hear What I Hear? I'm Jim Olson with the National Tile Contractors Association. I want to welcome you and thank you for taking time out of your busy schedule to attend today's webinar, sponsored by Ardex Americas. Before I introduce today's speaker, I want to remind you that during the webinar, you will be muted. Please use the questions area on your computer to type in your questions, and we'll answer those at the end of this presentation. If the audio on your computer is poor, call the number on the invite to this webinar and listen on your phone. All NTCA webinars are available to watch at any time on the NTCA YouTube channel shortly after the webinars are presented. This will give you easy access to watch and or share all current and past programs at your convenience. All right, very happy to introduce today's speaker. Thomas Utley is a technical consultant, tile and stone installation systems for Ardex Americas with focus on FlexBone uncoupling, FlexBone heat, in-floor heating system, and acoustic systems. He has been involved in the flooring industry through installation, sales, and distribution over the past 20 years. His specialty area is recycled rubber underlayments for use under most types of finished floor materials. Thomas began his research back in 2006 using recycled rubber underlayments for sound control under ceramic and porcelain tile. Being one of the pioneers for this type of assembly, Thomas worked closely with the mortar manufacturers and TCNA to test and validate this installation method. Thomas has created installation techniques for recycled rubber underlayments while working collectively with acoustical engineers over the years to identify acceptable methods and acoustical sound ratings. Thomas, welcome. We're looking forward to your presentation.
Thank you, Jim. And thank you everybody for attending our webinar today on recycled rubber sound control underlayments. So what we're going to cover today, what is rubber underlayment for sound control, approved materials for installation of those mats, both under and flooring above, the environmental specifications of recycled rubber, rating scales, comparable products that you might see out there, installation methods, and a few slides that discuss sound, what it is, how to identify it, and how to control it. So first we'd like to talk about what is rubber sound control underlayment. Well, rubber sound control, it's mostly manufactured using styrene butadiene rubber, SBR. It's manufactured by grinding up either car tires, truck tires, and removing all the steel banding and other things that are contained in, leaving with just crumb rubber. Actually, by using the recycled rubber underlayment, you're helping to keep over 100 million pounds of tires out of our landfill each and every year. So how is it produced? There's two ways. There's ambient shredding, which uses powerful knives to chop up the tires into the small pieces. They use machines called liberators that'll take all the contaminants and other things out before they clean it up. And then you have a cryogenic process which uses liquid nitrogen to actually freeze the rubber, becomes very cold and brittle, so then it can just be blasted apart with hammers into small crumb. Most often the non-rubber portions can also be recycled. So is it safe? That's the first question that I tend to get on recycled rubber. They want to make sure that it's safe. Well, many of the rubber sound control underlayments that you're going to see out there, they're actually floor score certified. So floor score was developed by the Resilient Floor Covering Institute, RFCI, and it tests and certifies the flooring products to conform to rigorous standards of indoor air quality and the amount of volatile organic compounds. So flooring products earn that floor score certification for performance in schools and office buildings. They can also assist specifiers by potentially contributing towards lead points. If you have a green building where you need to use recycled products, you get certain points for using recycled rubber. Where you source it, you get other points, and so forth. And the rubber underlayments and or even the adhesives that are used to put them down, they do qualify and they meet standards such as the California 01350 and the Collaborative for High Performance Schools, CHIPS. So I basically was one of the pioneers that brought these rubber underlayments to the tile industry back in, I think it was 2002. And everybody was concerned. They said, oh, we can't put ceramic and porcelain tile over rubber. They're going to break. Well, we've done a lot of tests over the years with the recycled rubber and ceramic and porcelain tile. And as you can see from the chart below, there's different thicknesses. The most common ones you're going to encounter are 2 millimeter and 5 millimeter, but you're going to find it in 10, 12, 15, all the way up to 25 millimeter thickness. So, but with ceramic and porcelain tile, the 2 and the 5 millimeter are commonly what you're going to use. As you can see, the chart below, the 2 millimeter, when we tested at the Tile Council of North America for that ASTM C627 standard, it gets an extra heavy rating, which is the highest rating you can get on that particular test, where the 5 millimeter jumps down to a light, which is just right above residential rating. So we'll talk a little bit about the differences in acoustical values on these as we get further down in. But one thing I like to point out, the recycled rubber, it also acts as a crack isolation membrane. As you can see, the ANSI A118.12 standard, this will bridge cracks up to 1/8 of an inch without allowing that crack to transfer up through and crack your tiles. And we'll talk a little bit more about, we're actually going to cover a lot of the ANSI 118 standards on the materials that are used in conjunction with the recycled rubber here shortly. So the common substrates that you're going to encounter, concrete, APA approved plywood, improperly prepared gypsum. The substrates and subfloors, of course, should always be rigid and free from movement and free from contaminants that are going to interfere with the bond of the adhesives that are commonly used to install these recycled rubber sound mats. So referencing the ASTM F710 standards, the subfloor should always be dry, clean, smooth, free of contaminants such as solvents, paints, sealers, curing compounds. And the subfloor should always be smooth to prevent the irregularities and roughnesses from telegraphing through or actually interfere in cracking a tile. Most of these manufacturers are going to say that that surface needs to be the equivalent to 3/16 and 10 feet or better. So another thing I want to point out, if you do have adhesives, paint residue, things like that on your concrete substrates, just make sure that those are always mechanically removed. You never want to use solvents. Using the use of the solvents are just going to push those contaminants and solvents down into the capillaries of your concrete, and then they're going to migrate back up through at a later time, jeopardizing the bond of your adhesive. Now, expansion joints, a lot of times when they put down these mats, all your saw joints and so forth, they're going to fill those in with patches and go right over them. But your true expansion joints, your moldable slabs, you always want to honor those expansion joints the whole way up through the assembly. Even though your rubber will bridge cracks of 1/8 of an inch, an expansion joint, you can experience vertical movement, which no membrane is really going to solve that. So your concrete, again, referenced in that ASTM F710 standard, it should always have a compressive strength of 3,000 PSI or better. And your concrete should always cure for a minimum of 28 days, be fully cured and permanently dry. So even though it's 28 days, you still want to do moisture testing. Anytime you're using adhesives, you always want to do a moisture test. Relative humidity per the F2170 standard is the most common. and you don't want to exceed the levels recommended by your manufacturer. Adhesive manufacturer, most of the time they're about 85%. We've seen these gradually go up over the years. It used to be down to 75%. Now you're seeing this commonly at 90 and 95%. Just make sure those vapor emissions are controlled prior to the installation. Now, if you do encounter more of a fast track and you can't wait that full amount of time, and you have to use a moisture mitigation system, most of these manufacturers are going to recommend that it conforms to the ASTM F3010 standard practice, which is a 2-component resin-based membrane forming system. Now, your adhesive manufacturers, most of them are not going to let you go directly over that. So when you put those systems down, a lot of times they want you to put a sand broadcast over top of them. They want you to put a cementitious product. Most of your adhesive manufacturers are going to say an 1/8 inch. So that surface is meant to be absorbent. Now, the only exception I normally see with that is some manufacturers will let you put a pressure sensitive adhesive over top applied with a roller so that fully flashes off prior to the installation of your flooring. So your wood substrates, plywood subfloors, most of these folks are going to want you to use an APA approved type 1 exterior grade plywood or OSB equivalent. Most of them are not going to allow you to use things like particle board, masonite, Luan, things of that nature. So APA approved 3/4 inch. The underlayment manufacturer, or some manufacturers are going to say that you need to use a finished grade underlayment over top of the subfloor. Again, it's up to those manufacturers to mandate how they want their particular products installed and what's acceptable. Gypsum substrates. Okay, gypsum substrates, that used to be a bad word in the industry. Like 20 years ago, people were afraid of the gypsum because it was weak and it would become friable, things of that nature. But the gypsum has really come a long way over the years. A lot of your gypsum now that they're putting down is 3,000, 4,000, 5,000, and even 6,000 PSI, more resistant to moisture. Just make sure that it's prepared according to the F2419 standards. So, and when you test that gypsum, according to the C472, the gypsum substrate should have a compressive strength of 2,000 PSI over wood subfloors and 3,000 PSI over concrete with a density minimum of 105 PCF. So we mentioned gypsum and concrete. One of the first things to remember that gypsum and concrete, they're not chemically compatible. So if you have concrete and gypsum, you try to bond them together, you get a chemical reaction called ettringite, which is going to actually destroy the integrity of the bond between those two surfaces. It's going to come hollow, and then you're going to have a failure. So address it accordingly. Those manufacturers are going to have specific standards if they're using a cement patch over gypsum, things of that nature. By priming it, some of them require you to double prime. Just make sure you're following the adhesive manufacturer's recommendations as well. So how do you apply these rubber membranes to the substrates? Most commonly, I've seen them put down with a moisture-cured urethane adhesive. You have some really good high-quality acrylics now that I'm seeing used in hybrids, combination urethanes and acrylics. Again, it all depends on the manufacturer. I have seen one manufacturer that allows mortar to be used to put down these mats, and we're going to talk about that a few more slides down the road and how that can actually be problematic. So most of these rubber underlayments, you normally use a 16 square notch trowel with the adhesive to put those down, but some of the membranes are really thin, like I mentioned, 2 millimeter, possibly 3 millimeter. That's a little bit too much adhesive, so they'll want you to downsize probably to a 32nd V-notch trowel. Just make sure that after you lay these membranes into the adhesive bed, you're rolling it with the appropriate roller, commonly either a 35, a 75, or a 100-pound 3-sectional flooring roller. So you get proper transfer of adhesive to the backside of your membrane. So I mentioned about some manufacturers that would recommend the mortar. What happens is your mortar, the amount of mortar that you need to put that mat down, you get displacement of the mortar, and you could have high spots and low spots, which could be detrimental to your assembly. Not just that, when we talk about acoustics, you get a rigid surface that penetrates the pores of that SBR rubber and is in touch with the hard surface above and hard surface below. So you're not going to get the sound rating that you actually need to meet those particular codes and requirements. Another thing is your mortar tends to take a little bit longer to set and get strong. So to get that bond strength where your adhesives, in 6, 12, 24 hours, they're good to go. So most of the manufacturers, the mortar manufacturers, engineered cements that sell these rubber sound membranes, they have different mortars that they will mandate that you use to put those down. Your rubber manufacturers that they just sell the rubber, they'll recommend specific brands of mortars, which may make it difficult in some cases for you to source your preferred mortar from your local distributor. So, but all major mortar manufacturers, they all test their mortars to the ANSI A118 standards. So you're going to have mortars, most of your rubber manufacturers say it's okay to use the ANSI 118.4, which is just your standard modified dry set cement mortar. But all those manufacturers have at least one ANSI A118.15, which is the improved modified dry set cement mortar, which is basically it's a higher performance. Generally, what I've seen when you step up with your mortar, a higher performance mortar, they have better bond strengths, a little bit more flexible, and you can achieve a little bit higher rating as far as durability when you test it for that C627 standard. There could be size restrictions on the tile that you place over these underlayments, and that could come down to the thickness of the rubber underlayment. Most manufacturers are not going to allow you to put smaller than a 6-inch by 6-inch tile over top of this. What happens if you put something like the small penny round tiles, you get a little bit too much deflection and your grout could spall. So that could be difficult. And we'll show you tricks on how to get around that as well here shortly. So we talked about the mortar. Now grouts, that's another thing that comes into play. Again, we're talking about the ANSI A118 standards. You have 118, 6, 7, 8, and 3, your standard or high performance grouts. And if you really want a very durable assembly, you can go with your epoxies, your 118, 8 or 118, 3s. Now the TCA offers floor tiling installation guide, which classes the performance that ASTM C627 standards. As you can see, the criteria down below here, extra heavy, heavy, moderate, all the way down to residential ratings. So I mentioned 2 and 5 millimeter are your most popular, where your 5 millimeter and above, that's when they're getting into that residential and light commercial rating, to where you're thinner, your 2 and 3 millimeter get upwards to the heavy and the extra heavy rating. So you use these rubber membranes specifically for where they're intended. Residential environment, of course, you're not going to have the constant suitcase, rolling loads, things like that, appliances. So you can get away with a thicker membrane. But when you get more into your more industrial environment, you want to stay with a thinner rubber. And testing is important. You always want to pick these manufacturers that supply these and they have testing, and more importantly, that are going to warrant the complete system, and put that in writing if required. So say the 2mm isn't going to quite get you to the sound attenuation level that you need to be at. You have to go with, you know, a 5, a 10, or a 12mm rubber. Some manufacturers will recommend that you put a layer of cement board, a CBU, over top of it, which it definitely works. You're going to get a substantially higher rating when you do that. Make sure they know how to put in writing how you're supposed to attach those cement boards, because you can't do it standard where you glue and screw those. Reasoning for that is you never want to run fasteners through these rubber membranes. Um, in the industry, that's what we call a short circuit. So that fastener is rigid. That goes through the rubber, which is actually going to stop that impact, that's impact sound, and it's going to allow the impact sound to go straight down through to your subfloor. You might as well not even put down your sound underlayment at all. So that's very important. So another very important thing is what we call perimeter isolation strip. And this is commonly overlooked in the assembly. So these rubber membranes, they stop not so much the sound, the airborne sound that you hear, normal conversations. They stop that impact sound like foot traffic, rolling loads, things of that nature. These perimeter isolation strips, they stop that hard surface flooring from touching the walls. If you take that hard surface flooring, even if you put your sound deadening membrane under it, that'll stop it. But if your rigid flooring touches the wall, that vibration goes across the room, hits the wall, and down into the unit below. These perimeter isolation strips are commonly 6mm thick, about 1/4 inch. Most manufacturers that make the rubber membranes, they can supply it in a rubber strip, but the foam strips tend to be more common over the years. Sometimes they want you to spot tack these along the bottom, or some manufacturers actually make a peel and stick foam that you can put around. And we're going to talk about that shortly, how you actually install those. So as you can see here, the diagram on the left, once you put down these sound membranes and you install your finished flooring over top, whether it be ceramic, porcelain tile, or even hardwood flooring, that perimeter strip at the top of your finished flooring, you want to trim that flush with your finished flooring. Okay, and that's keeping that 1/4 inch gap around the perimeter of your room to control that impact sound. Now, your baseboard, that's another very important topic. You don't want to put that baseboard directly onto the finished flooring because it's touching the wall. Again, that vibration's going straight across the floor, hitting that in the wall and down below. So we recommend that you leave a gap, like a 1/16 or at least a 32nd of an inch above that finished floor. And you can either leave that open or you can fill it with an ASTM C920 elastomeric joint sealant, as referenced in that ANSI 118.13, which is the standard for bonded sound reduction membranes. So we talked a little bit about sound. I just mentioned about airborne sound, STC, but impact sound are what these membranes are really designed to stop. That's the impact where you have normal foot traffic, rolling loads, vibrations like that. That stops that. These rubber underlayments are one of the best products on the market to control that sound. It was problematic a long time ago. There were all kinds of different items that they use, cork being one of the more popular ones, but we're going to discuss that here in the next couple of screens, why the recycled rubber tends to be a very good choice. So that impact sound, there's many variables that are going to come together to give you what's called an IIC rating. Okay, and that's either going to be your finished flooring materials, the underlayment, the type, and the actual thickness that we spoke of, the thickness of your concrete or your gypsum, and your ceiling assemblies or modified ceiling assemblies below. So don't be fooled by the hidden numbers and other variables that are left unseen. Some manufacturers out there, they'll just spout a high number. They'll say, oh, our product gets a IAC rating of 70. these membranes, they help your sound reduction by about 20 decibel points or down to like 3 or 4 decibel reduction points. Those membranes themselves are not going to get numbers that high. Okay, we're going to talk about that. Just understand that the membrane itself doesn't get numbers that high. So here's an example. Your 6-inch concrete slabs, they're going to produce an IC rating, a delta IC about 28 on average, where your 8-inch slabs about 30, 10-inch slab about 32. Take your 8-inch concrete slab with an IC reduction about 30. You got your sound membrane at 20, so you're about a 50 IC, but you can't just add these numbers up. There's no actual mathematical equation that you can use. There's a lot of different variables that come into play. Your finished flooring is a big one. So a long time ago, 20 years ago, carpet used to be real sexy. Everybody wanted carpet. Okay, when luxury vinyl tile and hard surface flooring, ceramic porcelain started becoming very popular, people started to remodel their condos, and all of a sudden they hear all this noise above. So it's very difficult to get numbers up to 70s unless you have help from a ceiling assembly below. So they do different things. They use isolation clips, double layers of drywall, open plenum space, insulation, things of that nature. All those add together to get those high numbers that you seek. Again, it's not uncommon to reach 50, 55, but the higher numbers, you need help from your ceiling assemblies below. It's not just the underlayment. So how do we see through all these numbers? So if you want to compare apples to apples on your sound reduction membranes, ask to see the delta IIC number. Okay, a delta IIC number is measured by the ASTM E2179 standard. So that's a lab measurement, what they commonly do over a 6-inch concrete slab with ceramic tile. And what they do is they'll go into the sound studio and they'll build an assembly over this 6-inch concrete slab with just ceramic tile and your mortar, and they'll tap on that tile. And in the room below, they have a recording device that measures that sound volume. So then they'll tear that out and they'll build that same assembly, but they'll put a sound membrane down first. And then they'll tap once more. They'll take those two numbers and they'll subtract them from each other. And that is the delta IIC, which is the amount of improvement that that sound membrane offers in that assembly. So, and if you ever want to compare to apples, it has to be the same across the board. It's got to be a 6-inch concrete slab, ceramic tile, not something like LVT or hardwood. They certainly do that test with those, but you don't want to compare a test if somebody's using ceramic tile versus hardwood or something else, because it's too hard to compare, if that makes sense. Let's just take a look at a few examples. I mentioned cork earlier, which was very popular years ago for sound reduction. These particular numbers, they're true, I know, because I work for a company that we sold recycled rubber and recycled cork underlayment. They're both recycled renewable resources, but look at the first one here. You have the 5mm recycled rubber, which is very popular, which with that delta IC that I spoke about, the recycled rubber has a 19 decibel sound reduction, to where you take more than double that thickness, a 1/2 inch of cork, and we only achieved an 18 decibel sound reduction rating. So that's why the rubbers started to become very popular in late 2000s and one of the most specified rubber sound underlayments on the market today. Look down a little bit further. Your 2mm recycled rubber, 16 decibel sound reduction rating. And then you have a 1/4 inch, half of that of cork only gets a 14 decibel sound reduction rating. So one thing I want to point out, Look at the 5mm versus the 2mm recycled rubber. It's only 3 decibel point sound reduction. Now, people think, oh, okay, well, I'm going to double the thickness of the rubber. That means I get double the thickness of sound reduction. That's not true. You see, it's incremental. It only increases by 3 decibel points when you more than double the thickness. So again, we spoke about the 627 standard for durability with your ceramic and porcelain tile over these rubber sound underlayments. The 2mm getting the extra heavy rating, where the 5mm normally gets a light rating. So where should you purchase these products? When possible, it's always best to specify one source for your flooring system. This alleviates finger pointing. If a claim should arise, even if you don't single source it, find a manufacturer that makes these rubber underlayments that has good relationships with these mortar manufacturers. So everybody can work together, give you proper recommendations, give you test reports, and more importantly, give you a full system warranty and be able to support every product in that assembly. So in review of what we discussed the environmental impact of the recycled rubber. The installation procedures, I reference a lot of ASTM and ANSI standards. Your adhesives, mortars, grouts, again, with the ANSI 118 standards, and that perimeter isolation strip. We talked about the assembly performance and the major differences between your thin and thick layers of your recycled rubber underlayment. And we spoke a little bit about your acoustical definitions and performance. Again, the ASTM standards that we referenced, some of the most common. And then the ANSI A118 standards that we referenced, the most common. So I've covered just about everything for the recycled rubber, and I'd like to open it up to questions. Anybody have questions on those products that I can answer for you?
Thomas, this is Jim. So we do have a couple questions here, and you gave a lot of information, but the nice thing about me hosting this is I get to ask my question first. So you made a comment about Delta IIC and how you can't compare a luxury vinyl to a ceramic tile. But my question is, why wouldn't you be able to compare that Delta IIC? If you're doing the same thing, it's on 6-inch cement, you're putting down a luxury vinyl tile and you're tapping on it, it will give you a number, right? How come you can't compare those?
Well, you can certainly compare them, but you can't compare to apple. Now, you can certainly test like a sound underlayment that's 2 millimeters thick. You can test that with a ceramic tile, and then you can test it with a luxury vinyl tile. Okay, so you can see which one you're going to get a better sound performance. But what you can't do is take a rubber sound underlayment and then take say a cork underlayment and test luxury vinyl over the cork and ceramic. You can't kind of compare it that way. There's no way to extrapolate the data, if that makes sense.
Okay, that makes more sense. I was just a little confused on what you were saying, Thomas. So no, great job. Okay, so here's our first question from our attendees, and it comes from Rick. And he asked, can latex thin set be used to install tile over rubber membranes to lower the sound ratings to the point they will not meet IIC ST requirements? Does that make sense?
No, I'm having trouble understanding. The majority of the time you're using a modified thin set mortar to set your tiles over these membranes.
Yeah.
But that's not going to lower your sound rating.
So I don't quite understand his question either. So a latex fortified thin set, will it be any different than a non-fortified thin set rating?
Not that I've seen.
Okay, all right. I think that might answer it. Rick, if that doesn't answer your question, quickly type in the rest of your question and we'll answer that. He also had another question on what's an example of an industrial application for sound control?
You have commercial kitchens where they do sound control. Um, you have large gyms that are over living spaces, large gyms, facilities over libraries. Even you can put these sound membranes to stop that sound from transferring to the unit below. Again, thin membranes in those heavy industrial and commercial type applications.
Great, great. Well, you either did such a phenomenally great job that everybody understands using recycled rubber underlayment for sound, or nobody is asking questions at this time. So Thomas, great job. Thank you very much. Attendees, thank you so much for attending another technical webinar from NTCA. This one was presented by Ardex. Our next program will be on March 27th. Invites will be coming out, I believe, later next week and following up before March 7th. So looking forward to seeing all of you there. Oh, hey, I'm going to stop right there because I have a bunch of new questions. Hold on. They just
All
came
right.
in. All right. Are the same EJ 171 movement joint spacings required over rubber membrane?
Well, remember I said your movement joints and expansion joints, those should always be honored the whole way up through your assemblies. Now, it's up to your actual recycled rubber flooring manufacturer to specify what's acceptable and what isn't. Some manufacturers will say certain things are acceptable, others will not. I've never seen one say that it's acceptable to go over a moving joint.
So not putting the, okay, I get it. You can't, you're saying you haven't seen anyone say they can put their rubber sound abatement over a movement joint, right?
That is correct.
Okay. So if you then put a movement joint in at that point, I'm gonna ask here, do you need to cut through the rubber and put it directly over that movement area, or can you do it over the rubber? Well, you just said you can't do it over the rubber mat, so.
Correct.
Okay,
You have to honor that joint the whole way up through the assembly. You would basically follow the guidelines established in the tile industry. If you can't install a tile over that moving joint, you can't install the rubber with the tile on top over that moving joint.
sure. So you cut the mat, my understanding is you cut the mat, you put the movement joint in, and you put the mat on either side of it, right?
Exactly.
Okay, perfect, perfect. We have a lot of people saying thank you, thank you. Here we got one. Can this be used in home bathrooms? Can this product be used for waterproofing floor?
Yes, one thing I forgot to mention in the slide, it's recycled rubber SBR held together with polymers, urethane binder, but it's not, it's permeable. Water will still pass through it. So the rubber membranes, they're not actually moisture barriers. That's a very good question. When you use it in bathrooms and you need to put waterproofing, it's important to use a paintable or other type of waterproofer approved by these recycled rubber flooring manufacturers, and they will tell you how to do that to waterproof your system. Good, great question.
Good, good. Okay, I'm going to go back to the movement joint. Does honoring the movement joint through the full assembly affect the IIC, Delta IIC number?
It does not. It does not unless you have your something underneath that expansion joint cover that goes down and touches the actual subfloor. That's the only way it would affect it.
Okay, great. All right, well, I've got a lot of people saying thank you, Thomas, saying excellent information. I know our technical team has been watching this and will be definitely learning from it. And again, thanks everybody taking this hour out of your time in the day. I'm sure you're all so busy and crazy things going on in your life, but these are great educational programs, and thank you all. Thomas, thank you. Thank you, Ardex. And Thomas, I'll be in touch later, okay?
Thank you, Jim. Thank you, everybody.
All right, bye, everyone.